Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book JamesS.walker. So let's start with the video. So here we are given that starting from rest, a boat increases its speed to 4.82 meter per second. So since initially it was at rest, so initial velocity would be 0 and the final velocity is 4.82 meter per second. Now we have to assume constant acceleration during the motion. Now there are two parts in the equation that we need to solve. In the A part, we have to find the average speed of the boat. Now since the acceleration is constant, so we can write that the average velocity will be equals to 1 over 2 v naught plus v. So 1 over 2 v naught, we have 0, initial velocity is 0 and final velocity becomes 4.82 meter per second. So that would be equals to 2.41 meter per second. So this is the answer for the A part. Now in the B part, they are saying that the boat takes 4.77 seconds to reach this speed, 4.82 meter per second. Now we have to calculate how far has it traveled for this time interval. Now since the average speed during this time interval is 2.41 meter per second that we calculated in the A part, so the distance traveled will be equals to the average speed during that time interval multiplied with time. So average speed is 2.41 meter per second multiplied with time is 4.77 seconds. So we can multiply these two numbers and we'll get the answer to be equals to 11.5 meter. Now here we are given that this equation represents the position of a ball as a function of time. Now there are four parts in this equation that we need to solve. In the A part, we have to find the initial position, initial velocity and the acceleration of the ball. Now if you recall this equation that we derived earlier, it is x is equals to x naught plus v naught t plus 1 over 2 a t square. And if you compare this equation, let me write here, x is equals to 5 meter per second times t plus minus 10 meter per second squared times t square. Now if you compare these two equations, we can write that here this x naught is 0. So x naught we have 0. That is initial position we have 0. So we can write that the initial position x naught is 0. Now here this is v naught and in place of v naught here this is 5 meter per second. This v is velocity. So by comparing we can write that v naught is 5 meter per second. So we can write that the initial velocity v naught is 5 meter per second. Now next one is, now in place of half a, it is written minus 10 meter per second squared. So if we compare these two things, we can write that 1 over 2a is equals to minus 10, or we can write that a is minus 20 and this is meter per second squared. So the acceleration we have a equals to minus 20 meter per second squared. So this is the answer for the A part. Now next we have to plot this equation on xt graph for time interval t equals to 0 to 2 equals to 2 seconds. Now to plot this equation, we can use any online calculator. So this is the graph we have obtained. This is x here and this is t here. So this is xt graph. We have obtained this graph by using an online software called Desmos. So now next in the C part, this is the answer for the B part. Let me write here. This is for the B part. Now next in the C part, we have to find the average velocity of the ball from time t equals to 0 to 1 second. So here this is time t equals to 0 and here this is time t equals to 1. We can also calculate the average velocity by using this xt graph. So these are the 2 points. Now if you join these 2 points, we obtain this straight line, and the slope of this straight line will tell you the average velocity. Now here this would be a little bit tough to find the coordinates here, so we can do one thing. We can use this equation to find the coordinates, or let me do in another way. We can write that average velocity is equals to delta x over delta t. This way also we can find. So this is xf minus xi divided by tf minus ti, and this is nothing but slope. It's one and the same thing, this delta x over delta t. Now the final position we can find by putting t equals to 1 here. So we'll get xf is equals to, this is 5 multiplied with 1 plus minus 10 times 1 whole square, and this would be equals to minus 5 meter. So here this coordinate is 1 comma minus 5. Now xi, we know it started from here, so xi would be 0, because here this initial position is 0. Or other way around, if you put t as 0 here, we'll get x as 0. Now we can easily find the average velocity. So v is delta x, we have xf minus xi, so minus 5 minus 0 divided by tf. Tf we have 1 second, so 1 minus 0, that would be equals to minus 5 meter per second. So this would be the average velocity in the time interval t equals to 0 to 1 second. This is the answer for the C part, this one. Now in the D part, we have to find the average speed of the ball for the time interval t equals to 1 to t equals to 2. Now we observe that for the time interval t equals to 1 to t equals to 2 second, the direction of the ball is not changing. Like here this is t equals to 1 second, and here this is t equals to 2 second. The ball is moving in the same direction. So for this case only, we can write that the average speed would be equals to the magnitude of average velocity. So first we're going to find the average velocity, and then we'll take the magnitude to find the average speed. So to find the average velocity, we can follow the same procedure. So average velocity would be equals to delta x over delta t, that is xf minus xi divided by tf minus ti. Now in this case, xf would be at time t equals to 2 second, and xi would be at time t equals to 1 second. So average velocity would be equals to, now we can put this t as 2 here, and after putting t as 2 here, we'll get xf, and this value would be minus 30. Now minus xi. Now xi would be at t equals to 1 second. This is xi, and this is we calculated earlier also at time t equals to 1. The position is minus 5 meter. So this would be minus 5 meter. Divide by tf minus ti. Tf is 2 second minus 1 second. So on further solving, we'll get this value to be minus 25 meter per second. But we have to calculate the average speed. So average speed is the magnitude of average velocity. So that would be, we can take this magnitude. That would be equals to 25 meter per second. Now one thing you should note here, that average speed is not always the magnitude of average velocity. But here we have write that average speed is the magnitude of average velocity. It is because the direction of the ball is not changing. If the direction would have been changing, like for the time interval t equals to 0 second to t equals to 2 second, the average speed would not be equals to average velocity, because the direction is being changed from positive to negative direction. But for this time interval t equals to 1 to t equals to 2, since the direction is not changing, thus we can write that the average speed is equals to the magnitude of average velocity. Otherwise we'll not be able to write this. Now here in this question, we are given with this table, and this table shows the data for the sled that slides from rest down an icy slope. Now at time t equals to 0, the position of the sled is 0, at time t equals to 0.5, the position is 0.36, and so on. Now there are three parts in the equation that we need to solve. In the A part, we need to plot the position of the sled versus time. So for that, you can use any online graphing calculator, or you can also use Google Sheets to plot this graph. Now by using the Google Sheets, we have plotted this graph. So this is the position of the particle at x equals to 0, and here this is time t equals to 1, 2, and so on. So this is the answer for the A part. Now next, in the B part, we need to find the approximate average speed of the sled from time t equals to 0.25 to 1.3. Now for this time interval, we see that the sled is moving in the same direction. So the average speed would be the magnitude of average velocity. So let me first plot the points. This is time t equals to 0.25. So here it would be 0.25, and this would be the point somewhat here. Now next point is 1.3. So 1.3 is somewhat here. So this coordinate would be approximately 1.3, and this coordinate, that is distance. So for distance, we can do one thing, we can make a straight line, something like that. So this would be approximately 2.5. So this is the coordinate, this is 1.3 time, and this is distance. Now at similarly, we can find this coordinate also. The time we have 0.25, so 0.25 comma. Now distance would be approximately 0.15 meter. Now we can easily calculate the average velocity from here. So average velocity, for that we can do one thing, we can join these 2 points with a straight line, and the slope of this line will tell you the average velocity. So average velocity, this would be equals to delta x over delta t. So delta x would be 2.5 minus 0.15, delta t will be 1.3 minus 0.25. This is the final position, this is the initial position. So that would be equals to nearly 2.2 meter per second. So the speed, the average speed would be the magnitude of this value 2.2, which is equals to 2.2 only. So 2.2 meter per second. So this is the answer for the B part. Now next, in the C part, we have to determine the approximate acceleration of the sled, assuming it to be constant. So we can assume that the acceleration remains constant through the motion. So we can take any two time intervals. This is, we can take to be the initial position. This is, so we can write this is equals to x naught at time t equals to 0, and this is time t equals to 2.5 seconds, and this is x. Now we can use equations of motion, which is x is equals to x naught plus v naught t plus 1 over 2 a t square. Now x naught, we have 0 here, so we can do one thing, we can put it here. This x naught is 0 plus, now v naught. Now v naught is the initial velocity, so initial velocity is 0 because it starts from rest, so this value would be 0 plus 1 over 2 at square, so at square as it is, and this is equals to x. So from here the acceleration would be equals to 2x over t square. Now we can put the values, so 2 times, now x we have, this is x, which is 8.8, so 8.8 divided by time we have 2.5, so we can put it here, this is 2.5 and it's squared. So from here we'll get this value of acceleration to be nearly 2.8 meter per second square. So this is the answer for the C part.